the Boolean condition is true for that row will be filtered as a yes and be included in the result set. And it can be any Boolean condition, even one that doesn't refer to the row. For example, here, 1 is equal to 1, and that's true for every row, so every row is returned. Using a comparison operator, now we'll select only those with tour ID less than or equal to 3. Hit F5, and there's the result. Pretty simple. And all of the normal comparison operators you would think of are true as far as equal, not equal, less than, greater than. A special comparison operator is the between operator. The thing to remember about between is that it is inclusive. Normally we'd say, pick a number between 1 and 10. In English we would then think of that as, well, 1 is not between 1 and 10, 1 is 1. But in SQL this is inclusive, so it does include 2 and 4. In fact, if we run both of these and look at the execution plan, let me turn that on and execute. Open up the result window. You'll see that SQL Server actually changed the between into a greater than equal to and a less than equal to right here. Another special condition we can have in the where clause is the in a set condition. Pressing F5 to execute. And this time we restrict the rows to only those where the tour ID is in the set of either 1 or 3. Now this looks very foolish at first because we're hard-coding 1 and 3. Why would we want to do that in a database, in a data-driven environment? But you'll see in a couple of lessons that we can substitute the 1 and 3 with a subquery that will return a dynamic set, which is very cool. Another real-world example of using this, and let me create a little more room for us. And I'm going to go ahead and assign some regions to some of the base camps. And the next query will then select base camps where the region is in the set of North Carolina, West Virginia. Go ahead and execute this. Sure enough, we only find the 3 with the region in North Carolina and West Virginia. Another condition is the like condition, which allows us to work with strings and wildcards. Notice that the multiple characters is a %, not an MS-DOS asterisk, and the single character is an underscore, not an MS-DOS question mark. This is because SQL is based upon the ANSI SQL, not on MS-DOS. Let me go through a couple examples here and show you. The first one is going to find every base camp where the name begins with the letter F and then has any number of characters afterwards in the string. F5 to execute. Finds Freeport, Fort Lauderdale. This one goes over to the customer table, looks for every last name that ends in SON, and there's a number of them there, and you can just glance and see that yes, it does filter that out. A word of caution, however, is that when you're filtering beginning with a wildcard, SQL Server is not going to be able to take advantage of using indexes. Think of how you would find in a telephone book everyone whose last name ends with SON. You'd have to scan every entry in the telephone book, and SQL Server has to do the same thing. So sometimes like can cause some serious performance problems. This example uses the square brackets so that it will find any customer with a first name beginning with either A, B, or C, followed by any number of characters. F5 to execute. And sure enough, the first names of Charles, Bob, Chuck, and Al show up, which begin with A, B, or C. Placing the caret in front does the exact opposite. This will find everyone where the first character is not in the set of A, B, or C. And sure enough, let me open this up just to prove it. No first names with A, B, or C are in the list. And a where clause can have multiple conditions. Of course, most of them do in real life. So to look at this multiple conditions, F5 to execute. This goes through and finds everyone whose customer's type is equal to 1, or first name like DAV for Dave or David, and customer ID equal to 14. Now there's a number of people with a customer ID of equal to 1. There are several with David and there's only one with customer ID equal 14. And the confusing part about this particular instance of having multiple conditions is that we're mixing an OR and an AND. ORs and ANDs have precedence, just like numerical operators. The multiply happens before the addition. And for where conditions, the AND executes before the OR. So in effect, this is functioning as if there's explicit parentheses where I just entered them. To demonstrate the difference, the next query demonstrates placing the parentheses explicitly around the OR conditions. Scroll down to that one, and you see what we're going to do now to walk through it will be where either customer.id is equal to 1, and there's a few of those, or the first name begins with Dave. Let me highlight and execute just those first two conditions. Press F5, and you see that there's several there that have either the name Dave or customer type 1. However, when that is then ANDed with customer ID must equal 14, the AND limits it down to only the 1. The point of this is to make sure that you explicitly identify the order you want those multiple conditions to go through by using parentheses. Always a good practice, and I always do that whenever I code.